Hi, this is Ram from Crossmind Studio. Welcome back to the chapter number 10 of Geometry Node Introduction series of Blender 3.0. And today's chapter is going to be absolute fun. We are going to work with a very simple, interesting node called Raycast. And it's going to be super easy. That's because the concept of the Raycast is not new to us. We have seen the lights, we have seen how the lights work, and exactly based on the same principle, this nodes work. So you have the object from which you can cast the rays, and wherever the rays hit on the next colliding surface, just like how you get the shadow with the light, you'll get information of the hit position, hit vectors, and the normals of the colliding object. All that you can use to influence any kind of information that you have on a surface. It could be instances, it could be displacement. You can set position of these points, or do all sort of things. So just like any other node in the geometry node, the node in itself is not going to give you anything from the ground up. You'll have to come up with a creative idea. You'll have to come up with something interesting for all of these things to give you something useful. So that is my attempt today, and we are going to work with a very interesting sequence that you've seen in the trailer. So instead of working with the basic Suzanne models or the default cubes, we are going to make yet a very simple animation based on this done sequence. I'll give you a very quick run through all the scenes, and just in case if you have arrived on this chapter randomly, please go back and watch this series from the start if you're a beginner who is learning the geometry node for the first time. In case anything you find confusing, just make sure you have seen the previous chapters for all of this to make sense. If you are a student or professional working in the animation design, motion design, and VFX industry, then check out Rendero. They have cloud-based workstation. They offer cloud-based services, and you can remotely work from any location, from any device, and access your cloud computers and projects. These cloud computers can handle all the animation, all the heavy tasks such as renderings and simulations. They have also upgraded their GPUs from the Titan series to A10G tensor-based GPUs now, which are much more powerful, and I have been using their services for quite some time now, and I really like the flexibility of working on the cloud-based workstation. So they have revised their prices, and based on the new configurations that they have, you can also try out their 7 days trial period, check out the benefits for yourself. So just go to their website www.rendero.com, and their subscriptions are now open. The limits of the limited seats have been lifted up, and you can also use the code in the description to get the benefits of the discount. So let's get back to the tutorial then. Alright, so here we are in a fresh new file, and I have this very basic setup. There is a cube. From one side I deleted the front face so that we can see what is going on inside, and there's a Suzanne facing front. So let's bring a new geometry node network. Now let me just bring up a Raycast node and see what's going on inside this. So right now we are working on this cube. In the Raycast node, there is a is hit and hit position, hit normal, hit distance, and attribute, and then we have target geometry, attribute, source position, and all that sort of stuff. So let's go to the front view. So when you connect this Raycast and target any geometry, let's bring this Suzanne head, or you can just bring it from the object info and pick it up. And once I target this Suzanne head, now what's going on is, now I can use this object. So the rays from this geometry are going to collide with this test geometry. And wherever the rays collide, all that information we are going to get through this node. So for instance, if you have, let's say, a few instances, I'm just going to bring few instances on point and bring a cube. These nodes are consume so much space for some reason. Anyways, so now I have these instances. So instead of instances everywhere, what if I could tell this instances on point that only the rays which are hitting this Suzanne head in the given direction should be used to scatter the cubes. Now that is what exactly is going on here. So let me just bring another join geometry node so that we can see the original cube here. If I change the direction of the cube, direction of the ray, the instance selection is going to interactively change from the ray direction. All right. And the ray direction is pretty simple to understand. These are vector coordinates. So X, Y, Z shouldn't be too difficult to navigate through. So the X is in the plus X, minus X, Z is upward, minus Z, and plus Y, minus Y. So if you want to move it towards the Y direction, then this should be pretty easy to navigate through. But anyways, there's a different method to effectively place your ray direction. What if I bring a simple empty? I have this empty here, and if I choose this empty and bring it here and use the location to set the direction of the ray, then wherever I move this empty, accordingly it's going to change the direction of the rays interactively. That is much easier than to manually scroll the number. Sometimes you might be guessing the ray direction. If you find it too difficult, then you can always do this. So that is the second way to change the ray direction. And the third way is bringing a field, which is a normal field, and cast rays from all the direction of the normals. So if I plug the normals here, then right now it's not showing me anything. That's because the normals of this cube are facing outwards. Yeah, so these normals are facing outwards. So we want these normals to face inside for this field input to work. So you can always flip the normals, and as soon as you do that, you can see all the normals which are like from here, and from here. So all the normals colliding with this surface give you basically the selection based on the normal direction. If you don't want to flip the normals in the object level mode, so let's say if you want to rendering this object and you don't want to flip the normal, then you can always bring a vector math node here in the geometry node itself and multiply the normal with -1. So that is going to flip the normal here, the input of the normals. So that does the exactly same thing, but much more convenient way. So anyways, so this is pretty basics of how you use the raycast. So now this was a hit position. So what if we have a, let's say, what if we don't want to use this selection, instead want to scale these instances based on some vector input? So we have a vector input of hit position. So wherever these rays hit on this Suzanne head, like here, here. So we want to use those positions of these vertices and accordingly scale or rotate these instances. So as soon as I plug these coordinates here in the vectors, you can see there's a gradual transition going on. And since these are not Boolean numbers, so you won't be seeing a harsh change, instead of sort of like a gradation, like a gradual transition going on, because the coordinates are changing gradually here. If I bring a vector math here and try to multiply this, so there's a very interesting effect going on. You can always use this with the scale as well. So let me just get rid of this cube. The scale is using the coordinates of the position. So if you look at the grid, in the center we have the default position on the grid. So the more we move towards the right, the y is going to be higher in the number. The more we move upwards, the y and z and x, all these three are going to be a higher number. So based on that, you can see there are varying sizes of cube. Any cube which is in the center, so since it's using the position to manipulate the scale, so center cubes are all flat here, like these are vertically tall. That's because the z position is much higher. Anything which is in the center here should be exactly 0, 0, 0. Like this cube have disappeared and we can't see any dimension. So based on these vectors, get these nice transitions. You can also use the normals. So let's say if we plug in the normals into so based on the normals, you have something going on now. So it might look like an exact same result, but there are finer differences. In some scenarios, you're going to see the difference much more evidently. So you can always combine multiple objects raycast and bring in different things and create some nice interactions. We are going to discuss a few examples in a moment. So this was about manipulating some instances, but what if we have let's try some different case scenario. What if we want to displace this mesh we want to displace this mesh, and wherever the rays hit, we want to send this mesh to those points. As soon as we do that, if we plug the hit position into the position, the whole cube is going to snap onto wherever it collides with the target object. So just keep in mind, this could be a bit confusing to begin with. So just keep few things in mind, that the rays will be generated from this object on which we are working on, and it will be sent out to the target object, and wherever these rays collide, based on that you'll get the inputs and outputs. So now we have the entire mesh wrapped around our Suzanne head. But what if we only want the rays which are actually hitting the target object to be wrapped around it? Then you can use these multiple inputs. You can also use is hit into the selection and hit position into the position. So right now it looks too abstract. That's because we are sending rays everywhere. Let me just disconnect that. So now only the rays which are coming from top are hitting this Suzanne head, and based on that you getting this displacement going on. So pretty simple concept. And you can also use hit position into the offset, and you plug that into you plug the normal into the ray direction, and you'll get the displacement in all the directions. And any changes you do in the mesh, in the position, rotation, it's going to give you some real-time interaction here. So pretty fun to work with. Now about the ray direction is pretty simple, like how further the rays should go from this object. So the farther the rays go, the much more area it's going to cover. So if I make it 0, the rays are actually not reaching the object. If I make it 0.5, 0.1, you can see the much more rays are being much more surface area it's covering. So if I move this Suzanne head downwards, you can see that the rays are only interacting when it reaches within its range. So that is there. And then one more thing, which is the attribute here. So basically any attribute you have onto this object, you can project that through rays onto the main object. So let's say if I bring in a texture called Musgrave texture and plug this here, and let's say this is a float. Yeah, this is already float. And then if I bring vector math and plug the attribute here and multiply this, so now what is happening is projecting a texture through this object onto the main object. So it's different than actually applying texture onto the main object itself. So let's say if I apply this Musgrave texture directly on this one, so this is a different result. And if I take this and plug this here, and from here if I take this and plug this here, this is slightly different effect. So it's a very subtle difference, but there is no better example I can think of at this moment. So this texture is following the topology of this cube, but if I project it through this one and send it out from here, you can see it's following the direction of if I make any modification on this object, then it's basically projecting from this object and following all the normal direction and position and texture and everything. It's not just the texture, you can also send out colors, you can also send out values and use it in the render. You can also send out like vectors. Let's say any other vector information you want to plug into here, maybe something you're bringing from some other object, you plug it in here and send it out here. I mean, I'm not quite sure of examples, can't think of it right now, and don't even want to complicate it at this moment. So let me just stick to basics for the moment, and we'll maybe discuss a few extra examples in the future. That is there, and this pretty much covers everything. So instead of just talking numbers and parameters and different vectors and all that, let's make something simple and fun for the very first day, for the very first interaction with the Raycast, so that your mind starts thinking around this node, and maybe you can come up with your own example. So to make today's assignment a little more interesting, we are going to go and type Mixamo in the Google and go to this site. So on Mixamo you can find some motion captures and interesting models. So just go to the character section, and here you have plenty of characters to work with. For our case, I'm going to use this model called James. And since I have kind of a music which is kind of a hip hop or something, this model goes well with it. So we won't be using any textures, we just want some dance animation on this. And there are plenty of animations, so just find something that works for you. And in this case, I think yeah, hip hop dancing, this works fine. So yeah, this looks pretty good, and you don't need to change anything, just maybe don't trim any numbers. We want the full length of animation. And once you have all of that selected, click on the download, and this is going to give you an FBX. So once you have the FBX, let's just bring it into Blender, the FBX importer here. There it is, hip hop dancing. You don't need to change anything, simply import FBX. There you go. You have your model and you have the entire animation. You don't need to change anything, do anything or edit any motion into this model. All you need to do is maybe for now we can hide all the armature that we have. We don't really need to tweak anything into this. This is your model's geometry and this CH06. That is what we need to work with today's sequence. So for the first example, we are going to create a simple grid around this and a dancing floor kind of a thing. So let's just bring one simple plane and click on the geometry node. And on this plane, maybe we can get rid of this one, bring this grid size, something like this. And then let's bring this character 06. Let's make sure that the ground plane have enough subdivision, something like this. And we are going to bring Raycast, target this guy over here. And yeah, so now we need some instances. Now let's bring our scale instances and plug this here. The reason we are using the scale instances here, that's because if we plug that here, it only gives us access to the scale, but not the center of the whole thing. I mean, in the scale instance, you can use the local and global position and change the center. So a few extra things you get here. So that's why I'm going to simply bring scale instance here. Let's bring a combine XYZ and plug that into the scale. Make everything one. And we only want to influence the Z direction, the vertical direction. And let's plug the hit distance into Z. And now what we want to do is map range this. Map range. Let's make everything 0 first. Actually leave it as it is. Something like this. And instead of linear, smoother steps should work. Now if we change the center, maybe 0.01, you'll see we are basically changing the center of from where the thing needs to be scaled. So if I have a cube here, if I scale this up into Z direction, it scales from the center. But what if I take the 3D cursor, just like how we take a 3D cursor and place the center here. And if I scale this now from the 3D cursor, it's scaling from this direction here. And if I do that from here, now we are scaling from here. So a little bit of offset. So exactly the same thing happening here. We are scaling this from a little bit of offset. That's because I don't want to see any of this happening on the positive side of the floor, but on the negative side of the floor. And just tweak a few more numbers. So you have a kind of a dance floor and these Lego kind of pieces are behaving in exact same way wherever the rays are being casted. And you can change the position if you want of the in which direction you want to send the rays into. Now you can do the exact same thing like what you have here. Maybe if I take this join geometry and plug this here. Now if we transform this grid, maybe rotate this one into 90 degree. Now for this, we are going to choose a different raycast because we need to change the direction. So plug this one into Z and change the direction of the, into the Y. Sorry, I forgot to copy the scale instances. I think the rays needs to, and sorry, instead of Z direction in the combine XYZ, we are going to use X direction. So yeah. And now if you, let's reset this, reset the offset and see what happens. Nothing much. Yeah. There you go. So something going on here and this looks fine. This looks fine. And with the materials and everything, we can make it better. And so you have your first sequence. And if you want to bring in any music, what you can do is simply go to the sequence editor. Where's the video sequencer? And just bring in a clip, just add a clip from here, add sound from here, and you can simply drag and drop on the and grab it, move it, do anything with it. All right. Now let's go back to the geometry node editor. So this is going to be our first example. Now let's talk about something else. So instead of using a flat sphere here, instead of using flat plane, what if we bring an icosphere and Click on the new node network. Let's bring an icosphere from the geometry nodes so that we can change the subdivisions later. So we have the icosphere, and now we need to bring in our Raycast object, the character, and we need instances on points. So yeah, so I had to make plenty of subdivisions. Let's bring a raycast here. So now instead of using rays into one direction, what we want is rays to cast in all the direction, like maybe make 4 or 5 projections out of it. So let's target this geometry. I'll decrease the instances for now. And whatever is the hit, let's use that. And use the relative. So now you can see here we have, sorry about that. I'm just going to remove this sound from video sequencer. Is there a way to lock mute? Yeah, mute strip. So now let's go back to the geometry nodes. So we have one projection. Now what we want is make multiple projections out of it. So let's do something else. I'm going to Control Shift D, the raycast node. And what this will do is keep the connections and make a duplicate. We want to change the direction of the rays and combine that input with this input here. So for that, we are going to use Boolean math and change this to OR and combine that with this one. And now if you change the direction, so basically we have multiple hit inputs being calculated with the math node here. You can make another copy of this, another copy of this, and combine that here. Change the direction and make as many copies as you want. So now we have 5 different inputs, and you can see the projections working fine. You can combine the original glass input with the joint geometry and plug that here. Maybe you can make a duplicate of the original geometry and plug that here and reduce the resolution because we don't really need so many points. Or much simpler thing, we can reduce these numbers and subdivide this mesh here. There you go. So you have instances now in multiple directions, and this looks fine. Maybe we'll talk about the materials, and something similar I used for this sequence that you see on the screen. And maybe you can combine the first example with this one as well. Make a grid on the ground and do the exact same thing with the raycast of this. So I'll leave the files on the Gumroad if you guys want to check it out. And here's one more example I want to discuss. So I'll just bring a transform node. So I just applied geometry node network onto this character itself. And let's bring a transform, a joint geometry node. And what we need to do is scale this into negative x direction. Sorry, not the rotation, but the scale. So now we have 2 characters. So we have the mirror going on here for exact same character. Let's bring a set position node and plug that here for the first character. So we want to displace few points on this character, the vertices, and project that and connect with this character. So let's bring a raycast node, and for the raycast we want to target this character. So plug this geometry and shoot rays and hit position can whichever rays hit with this character will be snapped onto this. So maybe I have to increase or change the direction into x direction. Yeah, something like this. Decrease the ray length. Let's see, something like this. So I think it's a pretty simple yet interesting effect. Maybe you can try out many things. You can just convert these into wires or something. Maybe make instances of wires on one character and shoot those out and send it to another character. So something like that. Now these will look much more exciting with the materials, which we will get back in a moment. This sequence that you see on the screen, this is the breakdown of that. I basically used simple emission with a texture So I'll get back to the material breakdown in a moment. So you might have to tweak these numbers. The closer these characters get, you have basically a reflection of one character, the projection of one character, and maybe you can do the same thing for the other character as well. And but the scene might get heavy. Or maybe what you can do is bounding convex hull. Bring the convex hull onto this character, and then what you have is this diamond like shape merging with the character that we used into the sequence against the yellow background. So pretty simple things. These were I mean, just for the tutorial purpose, I wanted to keep it simple, and I was trying to figure out what all we can do combining with the Raycast. This is not all, and I'm pretty sure combined with the rest of the nodes, maybe with the transfer attributes, with the proximity, there are so many things you can do with it, and we will discuss those examples in the future. But we can't make everything in one chapter. So there is one more example I want to discuss before we jump onto the material part. Let me just open a new file. Now for the last sequence, what I have here is there are 3 planes, 1, 2 and 3. So what I wanted was basically whenever this character slides under these passes through these different planes, the density and the effect changes on the character. So basically what I did was I'm using these 3 planes to cast rays vertically down in the -z direction and control the density, sorry, the selection based on that. So for the first setup, I have this grass kind of a thing. A very simple distribute points on faces and instances on the points. And I'm using a simple grass on this character. For this first setup, so let's say if this one is the grass. So as soon as the character stays under this plane, the grass stays on the character. But as soon as it exits, moves out of the rays of this grass plane, the grass disappears. So for that, I have this grass plane here, which is being the grass zone being targeted for the Raycast, and whatever hits this one goes for the under the selection. Let's use that to distribute. So as soon as this character moves out of this frame, the grass frame, let me just hide this as well. Control Alt B. I just want to change the viewport background to something darker. Yeah, something like this. And similarly for the second setup, we have a bunch of simple icospheres distributed on the distributed points. The scale is being randomized with the random value node, just everything similar to what we have already discussed in the chapter number 7, 8 and 9. And for the second setup, I'm using this plane, the bubble plane, the bubble zone, and targeting this one. Use this as selection. Now let's combine these two into a joint geometry node, and this is what you'll see in the render, how it's affecting the density of the selection of the distribute node. And for the third one, so for the third phase, I simply wanted to bring back the character. So in this, I'm using a delete geometry node, and what this will do is basically delete everything. I'm using the original input of the geometry, and in the first and second example, our original character was replaced with the distributed points, but for the third, I didn't distribute any point. I'm simply using the whole character and then delete geometry node. Let me just bring this one here. As soon as the character comes under this plane, it gets deleted. If you want to invert that effect, simply bring a Boolean math node and change this to not. Now the effect is inverted because now instead of deleting this, what this node is doing is whatever comes under this, do not delete that and delete everything else. So simple thing. And now let's combine all of these 3 things. I don't know why I have this so far. For some reason, I'm just being lazy. And just to make the visual a little more interesting, what I did was I made instances on, made duplicate of these planes and distributed similar things on top of these. On this one, I distributed grass. On this one, I distributed bubbles. And on this one, I made wires. Sorry, this one. And there's something different going on here. So let's talk about this. So on this plane, we have distributed some points. And on these points, we made some wires. Simple curved lines. And randomize the scale. And then realize the geometry. Exactly the same thing that we did on in the chapter number 8 and in the 9 as well. So then set position of only the starting points. Select the ending point 0, starting point 1. Again, the same thing that we did in the chapter number 9. And then for the position of these points, we want to target our character, raycast from here, and use the hit position to snap these splines onto this character. All right. Then after that, you can just set spline type to Bezier and set handles to smooth. Sorry about that. Something is going on. Just to add a little more interest in this one, I plugged in the normal of the raycast, a very random input into the set handle position. So at least I get some direction. So maybe you can try something else. You can try some texture, maybe some other manual vectors. That's it. So as soon as our character appears under this plane, wires snap onto our character. And now we are going to talk about a bit of materials. So I'll start off with the very first scene. And here for the ground and all the instances I'm using a very simple setup with the principal BSDF and using the transmission, the transparency to the max, and there is no roughness into the surface. For the colors, I'm using in the base color, I'm using a blue color which is being offset with the random object info node and with the map range of these numbers. And I limited the map range, the randomization with these numbers. So very simple setup. I'm not actually going to change anything here because my graphic card would interrupt the voice. For the character, I'm using simple yellow color in the diffuse, and whatever textures were assigned on from the Mixama file that we downloaded, I left everything as it is and only disabled the base color texture, the diffuse map, and instead assigned a flat color into this. So there is nothing much, and you know how to assign the materials into the geometry node network. We have discussed that in the chapter number 4. Simply bring a set material node and assign it from here. For this shot, for the glass sphere, I'm basically using a very simple principled BSDF as well here. And I combine that shader with a mix shader and using an emission shader here. And for the factors, what I used was a geometry input based on the position, whichever cubes are getting higher. So in the vertical, in the Z direction, I'm using a math node for that to extract those values and use that into the hue. So whichever cube vertically grows higher based on the Z direction, that will change the hue for the base color of these nodes, and combine that with the mix shader node. So pretty simple treatment. We have done plenty of similar tutorials in the past. For the glass, I'm using a very simple glass shader. Nothing going on here much. I simply decrease the index of refraction to 1.1 so that it's not really distorting the character which is inside too much. And for different shots, I enabled and disabled the world light, which is there, the interior.exr. For some shots, I turned these off and let the emission shader, which is being used on these instances. So for these instances, I used a simple emission shader. So the lights from these cubes will basically illuminate if you don't have any exterior light from the HDRI. That's all. For this shot where the transition is going on from the grass to the character into the spheres and then the wires, for this shot basically I used a similar setup. For the base color, hue of these spheres, the instances is being randomized based on the map range and the random input node with the object info. So that's what I used here. Just to make these spheres look a bit softer, I used a noise texture in the displacement. Not really a true displacement, but just like a bump. And don't forget to use the UV map attribute, because otherwise the geometry node will not wrap it up properly onto the surface. For the grass, I didn't actually change anything. Whatever texture was applied on the grass, that was automatically picked up. And for the character, the yellow color, I used the same color which we used in the previous shot. Basically base color, the yellow, and the wires are yellow. And here's the last example. And this one, basically I'm using a simple text object. So I made one text object which you get from here. And then once you're done with the editing, just extrude these. You can extrude these with the extrude command here. Then I made a duplicate of the front surface. You can see here I have two parts. One is this, one is the front surface. And then there is another part which I'm using to project the raycast. So because this one is just for the visual. On this I'm using this grass. And if I project this for the raycast, then it's going to pick all that grass and everything with this. So just to keep it clean, I made a duplicate of this one. And the rays from this are basically what we are using in the raycast here. So let me just show you the setup. So on this character, we have distribute points on the faces, and in the instances, I'm using the grass, and the grass is being scaled based on these random values. And for the selection into the distribution node, I'm using Raycast R in the projection of the R, and these are I use basically manual numbers to pick up the direction, but you can bring an empty to make this work easier. That is all there to it. So if I change the direction, based on this shape, everything changes. So as soon as character steps into this range, you can see the negative and positive of the R affects the density, these numbers. So pretty simple setup. And just to guide the visual for the video to complement the theme, I just made these lines which are connecting to this side of the R, and so that the character steps into these rays, becomes part of the grass, and as soon as he steps out, moves out, all that grass disappears. So just a bit of a thought around the composition. So for this shot here, what I did was combine two materials. One is the glass and one is the emission shader. So let me just render it out. So basically we have this magic texture here, which is being, the scale is being influenced with this muscle texture. Now this goes into the hue saturation just to bring in some color, and this color goes into the glass. And since the glass in itself is not going to show up here without the light and everything, so what I did was I used the emission shader and plugged the same texture into the color and combined these two to make shader. And these textures are animated. I brought one value and just type in frame and divide it by some number, hashtag frame divided by 150. So this will give you a running number, and you can plug that number into the time factor, the W of the 4D texture, so that the texture is always moving. I mean, this was a very happy accident, and this turns out pretty good looking in the render. I wasn't actually expecting to use this one, but the rays and the lights and texture and both of the sides of the character, the projection, I think this looks good. So maybe a bit more effort, you could come up with even greater results. But for this tutorial purpose, I think we'll have to put put a stop to meet the schedule and everything. That's about it for this chapter. And once you have everything rendered, and in case if you render it out, just try to think of a theme around it. Just download some music, and based on the rhythm of the music, just see what you can think about the visual. And since this was a hip hop music, I downloaded a character which kind of goes with it, and the motion and everything looks fine. And try to connect your shots with the motion of the character, and try to stitch your shot with the motion of the character, so that the one motion carries and connects with the second shots the motion. So if you randomly cut your sequence here and there, then it's not really going to look great. Just try to stick to the motion of the character, and it will fall into place. So that's about it, and hope you enjoyed this session, and hope that you follow along and make something useful out of this. Let me know what you guys make out of this one, this sequence. Tag me on Instagram with Crossmind, and I'll leave these files and all the future files from this series. In fact, all the previous files of this series are on Gumroad, my account. Just go to the Gumroad, and the link is in the description and in the banner as well. So you can download these files from this collection, Geometry Nodes Blender 3.0. All the previous files and all the feature files will be there. Even the sequence, the title sequence we will be discussing. I think we might be adding these files as well. So since there have been changes in the geometry node, we might have to rework on some of these scenes, but I'll see what the best I can do with this one. And all the previous files are there. You can check these out. And if you get these files today, all the future updates will be free without having to pay any extra price. Go check that out. And also, I encourage you to make something of your own as well. Think of an idea, think of music, think of a theme, come up with some visual. And it doesn't have to be some complicated effect. It could be a really simple thing. Just try to manage your efforts and don't put everything into just the geometry node. Try to think of a composition. Try to think of colors, scheme, try to think of a theme, music, and work on an edit. And yeah, you'll be surprised. So I think we have covered pretty much basic nodes, all the basic nodes. The only thing I want to discuss in the future chapter is the attribute transfer node and the capture attribute node. So we will do that in the next chapter, and the chapter after that is going to be really exciting. It's going to be about the generators. Basically, we will be making a basic node setups which can be used to generate different effects. So let's say if you want a generator for the stones, so that whenever you bring those node groups, you can just stack number of stones, the randomized shapes of the stone, or let's say a generator for the pipes or the cords, or maybe the fences on the ground, the grass on the ground, or maybe some birds or something. So it could be anything, stairs or small things, maybe books on the library shelves. So we are going to talk about how you can start with the very simple things and make simple generators for yourself, so, sort of like a plugin, and use that node group in the rest of the projects and save it for the future use. And yeah, I think it's a time that we start talking about much more beneficial part of the geometry nodes. So that's about it for today. Enough of the talk. Leave the rest for you guys to explore. Check out the geometry nodes, check out the Raycast, check out this playlist from the very first chapter. If you are new to geometry nodes, the link is in the description. This chapter is the number 10th chapter, and we have discussed all the basics in the previous chapters. So stay tuned. I'll see you guys in the next chapter. Take care. Bye-bye. Bye.